Teacher.
Okay. Identify the index and the radicand in each of the following. So first of all, how would I read this?
The fifth root.
So the 5 becomes the 5th root and then 75. So what is the index?
5.
And the radicand?
75.
Good. How do I read B? Square root of 50, so what's the index? And the radicand? I can also read this one as root 50. So the square root or root 50 means the same thing. So you're going to hear me say root 50 a lot, or root 2, root whatever, instead of saying square root. And how would I read this one?
5 times cube root of negative 1 over 10.
Okay. 5 times the cube root of negative 1/10. What's the index?
30.
What's the radicand? Negative 1/10. Not sure if I gave you assignment question number 10. Let's grab our calculator. If I take the square root of 9 and I multiply it by the square root of 4, what do I get? Okay. If I take the square root and open up a set of brackets of 9 times 4, what do I get? I get the same thing. So when I'm multiplying radicals, I can either multiply them, I can find out their roots and multiply them separately, or I can multiply them together and then find out the root of the product. Okay? If I go the square root of 9 divided by the square root of 4, what do you get? Okay? Now, if I do it together, the square root of bracket 9 divided by 4, what do you get? 1.5. So the same thing when I'm dividing. Square root of 9, which is 3, plus the square root of 4, which is 2, equals 5. What's 9 plus 4? 13. And what's the square root of 13? Is it 5? No. So when I'm adding, I cannot push them together. If I subtract, square root of 9 was 3, the square root of 4 was 2. What's 3 minus 2? 1. What's 9 minus 4?
5.
What's the square root of 5? It's not 1. So those were the results from question number 10 in the previous lesson. If I'm multiplying radicals, I can do them separately or I can put them together. If I'm dividing radicals, I can do them separately or I can put them together. If I'm adding and subtracting, I cannot.
They have to be separate.
They have to be kept separately. I have to calculate them separately. So the product or the quotient of the roots of two numbers is equal to the root or of the product or quotient of the two numbers together. So product and quotient I can put together. Sum and difference I can't. So in general, the square root of a times b is equal to the square root of ab. Or the square root of a divided by the square root of b is the square root of a over b. I did this one when I did the fifth root of 1 over 32. I split them up and did the fifth root of 1 over the fifth root of 32. The condition in here is a and b can't be equal to 0 because then I get 0 and it's just, we don't deal with that. So if I look at class example number 5. The square root of 3 times the square root of 6. Will that be equal to the square root of 18? Yes or no? Can I multiply these two together?
Yep.
And do I get 18?
Yep.
So this is true. Can I divide these two radicands and get the answer?
Yep.
Yes. If I take the square root of 16 and plus 9, is that the same as the square root of 16 plus the square root of 9?
No.
No. 16 plus 9 is 25. Square root of 25 is 5. This is 4 plus 3, which is 7. This is false. Class example number 6 says put this all together. Square root of 8 times the square root of 3 would be the square root of 24. Square root of 7 times 3 would be the square root of square root of 50 divided by the square root of 10 would be
5.
square root of 5. 50 divided by 10. This one you got to be careful of because I've got the square root of the square root of 100. So do this first. What do I get?
10.
So
Square root of 10.
I get the square root of 10 over the square root of 2, which would be
Square root of 5.
square root of 5. Express as a product of radicals. How could I take 77, or the square root of 77, and write it as a product of two radicals? What would I get?
11 times 7.
11 times 7. Can I write 7 times 11?
Yep.
Yeah. So then I could split this up, the square root of 11 times the square root of 7. What about 27? 9 and 3. So the square root of 9 times the square root of 3. What about 40?
4 and 10.
Can I do another one?
5 and 8.
Is there any other ones I could do?
2 and 20.
So I could have 3 different products that would represent the square root of 40. Okay, your questions. So 4, 5, 6. 8. For question 9, let's do B, D, F, H, and then 11, 12, and 13.